So thank you all for coming, and thank you, Matthias in particular, for inviting me. You can attack him later. So this is about what I've been working on the past few years, which is a language called Newspeak. And the idea, a principal dynamic language is not an oxymoron, but really this is actually a dynamically typed language that is geared towards software engineering and doing things the right way. So not necessarily, some people may think there are other dynamic languages that are like that. I won't comment. But basically, it's a class-based language, and what makes it interesting are two properties that are sort of defining properties that are the basic principles that everything is designed around. Basically, you as you'll see, you stake out these principles, and the language more or less designs itself from that point on. So those are, of course, the fact there's no global namespace whatsoever, and that has interesting properties. For example, if there's no global space, there's no global data, there's no statics of any kind, and that's a good thing for many reasons, which probably don't need to belabor, and I don't have probably time to go into all of them. It's all good and well to say you don't have any static state, but this is an imperative. At least this dialect is imperative. There's sort of work going on even a purely functional variation of this. But as an imperative language, a lot of people are bothered by the question, okay, there's no static state, but where does it really go? Obviously, it goes in objects, but you have lots of state that goes in objects, but the whole point of static state is that it's state that has to be shared among many objects, and you typically don't quite have a single object where it seems to make sense to put it. And the answer for that is an old answer. It's been known for 50 years. In fact, most of the answers in computer science have been known for 50 years, or 30 years. Basically shared lexical scope, right? This goes back to Algol 60. And in a class-based language, the natural solution is nested classes. And those of you whose experience with nested classes comes from Java, just forget that. Okay, let it heal. And if you I don't know if there's anyone here who knows beta. Okay, yeah. So they invented object-oriented programming, and they also invented nested classes. And they were the inspiration, by the way. I know for a fact they were the inspiration for the nested classes in Java. However, didn't quite work out the way it was intended. Largely because simply beta is a very uniform language, and all the power comes from the compositionality that you get from this uniformity. And that uniformity never existed in Java. By the time you were adding nested classes, well, there were rules for the types and the fields and the classes and the methods, and they were all different. And then what becomes compositional is the irregularity, right? The number, instead of an explosion of power from composing things regularly, which is what you aim for in software, you get an explosion of complexity when all these different rules kind of interact in all places. And this is wonderful because, I can spend 10 years getting paid to sort it all out. It's boundless. But real nested classes done properly are wonderful for a number of reasons. They're great for modeling because most problem domains have a hierarchical structure, and that maps very naturally into this nesting structure with classes. And they are a natural modularity solution. Lots of people who look at nested classes or class-based languages have the intuition that really basically we should be able to organize things using that. But in practice, it never seems to work out, right? It's not that easy to pull it off. But it can be done, and it is a natural modularity solution. And in Newspeak, that is what happens, right? There are no packages, templates, bundles, modules, units. There's so many names for all these extraneous things. Classes are the structuring concept, and top-level classes act as module definitions. And it all works out rather nicely, in my unbiased opinion. So the other defining property of this language is that all names are late bound. And when we say all, we really mean all. So, for example, you can think of it that every place you see a name, you can think of it as a first approximation that it's a virtual method call. Right? Message send here is sort of Smalltalk terminology that predates the common association today of messages with asynchronous. So you can think of having synchronous and asynchronous message sends. The synchronous ones are just virtual method calls. The asynchronous ones are for actors and stuff like that, which is something we're starting to work on only now. But basically, it's a very natural fit. And a slogan to capture this, which is a well-known slogan that you've probably heard a million times and is widely used in the Java world, and it's good advice, is to program to an interface, not an implementation. The difference is that in Newspeak, you can really do that. In fact, you have no option, because that's the only way to make it happen, is because if you give people the option to do it otherwise, they will screw up. So everything goes through an interface. An implication of this is everything is an object, right? A lot of people, me among them, have always advocated that, an object-oriented language really isn't object-oriented unless really everything in the language is an object, and that's a good design principle, but it isn't the design principle here. Here it's simply an artifact of the higher design principle of programming into an interface. By interface, we mean more or less what you think of in Java, a procedural interface, a bunch of named procedures. Not exactly what you think of in Java, because Java interfaces have a few quirks like classes nested in interfaces and fields in interfaces, rather weird things, but the typical real use of interfaces, right? Now, if everything's an interface, well, everything is an object because you can't talk to anything any other way, right? So it actually follows. For example, one of the artifacts of this is right. You can't refer to variables directly because you can define variables, but you cannot refer to them because you can only refer to things through an interface. So in practice, when you define a variable, you get accessor methods automatically. And you're really using those accessor methods whenever you use the name of a variable as actually a getter method, right? And this goes not only between objects, but internally within the object. So when you talk to self or this, right, that too is going through an interface. So nobody, not even the code within the class itself, cares what its representation is, right? If you want to get rid of some instance variables, which we call slots, you do that as long as you preserve the interface. You replace it, say, with a getter method that computes some value for this, etc. Then no one will be the wiser. Not other objects, not even your subclasses, not even the code in the class itself. Nothing needs to change. So that's kind of a nice property, but that's kind of not really enough to justify a language. Where things get really interesting are that you can't refer to classes either, because you really, the only thing you can refer to is a late bound name, which is basically an accessor method. So when you define a class, essentially you've defined an accessor method that gives you the class. This, of course, implies that classes have to be first-class objects, right? This is the same as, it's another example of the fact that programming to an interface implies that everything's an object, right? It also implies interesting things like classes are virtual, always virtual, right? You can override a class in a subclass with another definition. And the nice thing is you didn't have to do anything special here. You didn't have to say that we want virtual classes, that we're going to design them in, consider them. It just happens. It follows automatically from these principles. You can't have it done any other way. You don't have to specify that it's virtual. You don't get to choose. Everything is late bound. Now, because all names are late bound in this way, classes also implicitly define mixins. Again, without doing anything special. Because the superclass that you define is also just a message sent. And so this class, the subclass, the body of the class, the actual definition of the class, can be bound to some other, it isn't statically tied into some particular place, into some hierarchy, because you can override it, right? And we make that a little more convenient syntactically, but basically that property is already there. And that means you can do class hierarchy inheritance. You can define an entire hierarchy of classes, a library, a framework, whatever, and you nest it in some surrounding class. And then if you decide that you need to change something, one point in that hierarchy has to change, you specify that change in a subclass, and the entire library has got this property, right? Again, through overriding or through use of virtual classes. So these are all very nice and fairly powerful properties, and they all fall out completely automatically from just deciding to be serious about this idea of using interfaces for everything. So now I'm gonna do
That line, concepts are phenomena. I didn't.
Okay, so you might be, if you're the only guy who said I think who indicated that they know beta. So you may be the only one for which this slide has been aimed at people who are more into this, right? So beta has this whole philosophical spiel about concepts and phenomena. So the idea of being that classes or patterns really in beta are describe concepts, and objects are the actual phenomena, real things, right? And much is made, right? There's a whole sort of thought process and methodology, that the folks in Aarhus developed around this. And this distinction is something that this is one of the points where I've disagreed with them, because this doesn't really allow for much in the way of metaprogramming, of treating programs as data, all that kind of thing, right? Because there's a sharp line between the concepts and the phenomena. Now, if classes are first class, right, this is much more in the Lisp, Smalltalk, self-tradition, right? So the point is that concepts are phenomena too. And this, maybe I should take it out, because it's a distraction for most people, but it is a point that Ola needs to hear. Yeah.
Related to you saying that classes are always mutual inclusive mixins and so on. Does that mean that the language supports like these class competition mechanisms as first class sort of concept, or is it something you can actually program in the language? How to combine classes?
So I'm not sure what you're referring to. If you're thinking of like sort of class or module combinators, sort of like Jigsaw, like my pieces, yes. No, there's no real support for that. You could program that at the meta level reflectively, but there's a very clear separation here, as we'll get to, between meta and base with mirrors and stuff. So that really isn't there. I mean, the only real combinator is regular subclassing. Okay. And it would be interesting to add that. Obviously, I am not averse to the idea, but it doesn't do the Jigsaw style operators.
And you've got multiple inheritance.
What?
You do have
okay, so mixins, in my mind, subsume multiple inheritance. What you need to do, the reason you wanted multiple inheritance, to do that, you can use mixins, and they have a lot less problems. And mixins just happen, and so no, we don't have multiple inheritance. We don't want, never want to hear or see it again.
Fair enough.
I'm not very opinionated about these things. So I want to do a quick kind of review of the syntax, because I expect that I don't know all of you, but I think there are about 2 or 3 people here who would otherwise be able to read the examples as we go on. So we're just gonna do a quick go through the basics of the syntax before I sort of switch to a demo and kind of illustrate all these points more concretely. So x space foo means x dot foo parent, right? And the stuff in red is stuff you don't need. This is no surprise to some of you, but right, why do you need these parentheses? Well, they're used to, you need them because you have to distinguish in most languages between an access to a field or something like that, and a method that takes no parameters, right? We don't have that distinction. Everything is essentially a method call, so we don't need to make that distinction, and that has a nice property. If there are no parameters, well, guess what? There really aren't any. You don't need to say, here is the list of parameters that don't exist.
But doesn't it also give you the distinction between time of evaluation? So in a language where methods are really functions, x.foo without the bracket means getting the closure, and then adding the brackets in actually means evaluating the closure.
Right, you never get the closure.
Okay.
I would argue that in object-oriented programming, it is of cardinal importance never to separate that closure from its object And so you don't get the closure. It doesn't work like whatever, probably Python and whatever. No, you execute the thing. If you wanted the closure, you put it you store the closure in a field, and you have an accessor for the field, and right. But we don't have that distinction. So similarly, of course, the dot. Well, the dot is the object member selection operator. Since the only operation is select a member from an object and execute it, you don't need to say that. And as we'll see, this isn't really the main topic of this talk, but the syntax actually works really well for domain-specific languages, and a lot better than the conventional syntax. So we're happy to get rid of the dot as well. Binary expressions are kind of what you'd expect. So the thing to realize is that this 3 factorial binds tighter than the plus. And if you translate it into something that's more intuitive, it would look something like these guys, which you actually typically can't write, of course, but you get the idea of what's going on here, right? Then this is the one that's probably hardest for people to digest, the so-called keyword syntax. And, again, the binary expression here is binding tighter than the keyword. So we're sending Windows a method call called version : and the arguments to that are the result of this expression, 7 plus 0i. And 7 plus 0i is a way to write a complex number, of course, and that's an example of how the syntax works better than conventional syntax, because there's no special support here for complex numbers, but you actually can express that very naturally. And so it's equivalent to all these things, right? So this shows that the precedence of the binaries is higher than the keywords, and the precedence of this is higher than that, which we've already talked about. And that's what you'd expect if you look at how you would code it in conventional syntax. And there is well, first of all, if you have multiple parameters, you have multiple keywords, and the order of the keywords is significant. So it isn't really a keyword syntax in the sense that just the name matters and you can shuffle it about. Add 1 to COBOL is not the same as to COBOL add 1. Right? Those are different methods. And the real reason that I have stuck to this syntax, which of course goes back to self and Smalltalk, and is a barrier to adoption. Well, there's 2 reasons. One is, yes, it works much better for domain-specific languages, which in the original scenario for Newspeak was an important use and still is. The other real advantage is that in a dynamically typed language, it's very useful because you don't get errors. Unlike, say, JavaScript, where if you get the number of arguments wrong, you go into some black hole somewhere. This can't happen syntactically. It's generally much better to control things through context-free syntax than it is through all kinds of fancy mechanisms like type checkers. Context-free syntax is one of the very few things that we actually really have a handle on, that we really understand and really work. And type systems are one of those we don't and never will. But that's another one of my unopinionated sort of sidelines. So yeah, let's go back to the language. The goals of this language, broadly speaking, are to combine these 4 things. Support for modularity, security, reflectivity, meaning the dynamic stuff, right? The ability of programs to change themselves while executing, things like that. And as you can imagine, security and reflectivity, there's an interesting tension there. And still to interoperate with the, quote, real world, the nasty stuff that's out there, as opposed to, say, Smalltalk, which tends to huddle in its beautiful little world and doesn't talk to the nasties outside, which is a big problem. So at this point, I think I'm going to switch to the demo. Now, I don't know, can you see it, or do we need to sort of zoom this in? Because zooming on Windows is very flaky. But
works for us.
Okay, and the other people, the people far away, have muted their mics, so they can't complain. Anyway, what this particular example that you see, this is the Newspeak IDE running here, and it's showing you a class called combinatorial parsing that represents a parser combinator library. I'm not even sure if everybody knows what that is, but it doesn't really matter because I don't have time to discuss what this library is. Kind of really neat, but I don't have time to really discuss what it does. I want to illustrate sort of program structure here. So it's a library, right? So down here we have a whole bunch of classes nested inside. This list represents some classes that constitute that framework, right? They're all nested inside this enclosing class. And yes. So for example, this nested class combinatorial parser, that happens to be the root of this whole class hierarchy. So almost all the classes here, there may be a couple of support classes, but almost all the classes here are subclasses of combinatorial parser, right? And if we take a look at this guy, then what I wanted to show you is just this particular method, and you don't really need to know what it does or anything. You have to just notice this thing, that it refers to a name here, ordered collection. Now, ordered collection is generally speaking a class. It's been renamed since, actually, but it doesn't really matter here. But it's a class that say, it's now called mutable list, which gives you a better idea, perhaps, of what it is, right? It's like a Java mutable array list or something, right? It's a collection class. It comes from the collections library. We need to use it here for some purpose, right? We're building some structure, and we need collections. So this library doesn't define collections. Obviously, that's a different library. On the other hand, as I said, there's no global scope. So where does this name come from? That's kind of the issue. And if we go back to the enclosing class, then we see actually, well, here it is. It's defined. This is actually a field, a slot, defined in the enclosing class. And it's being initialized here to the expression on the right-hand side.
Are fields like that mutable or not?
What?
That's a mutable field or not?
This in particular is an immutable field.
Okay.
That's why it says equal.
Okay.
Equal actually means something. And there is a syntax that's with a colon equal that lets you define a mutable field, right?
Okay.
Now, in fact, that's an interesting point I was going to get to. So how do we make it an immutable field? There's no type checker, there's no static analysis going on to enforce any of these things. However, if you declare it this way, we will generate a getter method, and we won't generate a setter. And since you can never refer to the field itself, you're really only referring to the accessor. If there is no accessor, well, you're not going to change it. And so it's pretty immutable. Now, you can do all kinds of things reflectively, right? Once you go to the meta level, all bets are off. But in your regular program, you just will not be able to change this field after it's been initialized. And this code right here, let's look at it in a slightly different view. This code right here is, this is called the instance initializer, right? This is code that gets executed when an object gets created. The way this works, the way you create an object, you send a message to its class that to basically invoking a factory method. Factory method creates an instance and then invokes the initializer. How do you define the factory method? Well, this guy right here, that's a method header. This stuff, well, I'm off by one character, right? This is a method header, right? It's a method called using lib colon with a formal parameter platform. And the class is called combinatorial parsing. And if you actually put this in a file, the syntax would be slightly more conventional. There'd be class in front of it and things like that. But we don't show it in the IDE. Now, what does this header do? This header tells us that we want to have a factory for this class called using lib colon. And so the class object, not the instances, the class object will have a method called using lib colon that will create an instance and invoke the instance initializer running this code. So one thing to note here, this basically means the factory pattern is built in, right? You never have to define factories or think about it. Classes are always factories, right? And that means that I can take build an arbitrary object with a using lib colon that, pulls objects out of a cache or instantiates a different class or computes it or what have you, and I can send it along and no one will be the wiser unless they're actually trying to subclass it. But if they're using it to manufacture instances, it's indistinguishable from a factory object, which is, again, an artifact of using interfaces consistently, right? So there are no constructors because constructors don't build. Interfaces don't support constructors. Constructors violate abstraction in a really big way. Now, the formal parameter platform, well, this is an idiom, right? It's very typical. I mean, the name here could be anything, right? We can name it any method name with any number of arguments, but very often we use this idiom. Platform is supposed to be an object representing the enclosing environment, the programming platform. And what we do here, we send platform the message collections, which will we expect it to give us a collections library back, an object that is the collections library. And we can ask the collections library for the class ordered collection. And that's what we're doing. And we store it in a field because these formal parameters are in scope only in instance initializer. So if I actually aim to use them in the body of the class, I'm going to have to extract them and store them somehow.
Let me just have,
Yeah.
what is it that makes it an instance initializer?
It's magic. This is the
Right, but how do I tell it from the syntax? So what part of is it the...
Okay, you're not really seeing the syntax because we're looking at a structured view, right? We're not seeing a file, right? But if we look at, say, let's go back to here, right? So these are the instance methods, right? Things like this, right? They appear later on in the file. There's actually, the parentheses are lined up, and they'll turn into curly braces once I get round to it, so that I have to stop explaining this to the world. But the syntax is such that there's a section that identifies this. This is where all the slots are defined, and their initialization expressions are there, and that's what makes it the instance initializer. So when you create an instance, we'll basically extract this class from the ordered collection library, which we get from this platform argument, right? The point is there's no global scope, and everything I want from the world that has to come to me through these parameters, right? All the names I'm using have to be defined in this class, or they're abstract and they'll come from a superclass. Right? There are no global names.
Surely there's a bootstrap somewhere.
Yes, but we use tools. We'll get to that toward the end of the talk, right? This is the stuff that drives people nuts. It's where do I start? What do I stand on? Of course, that's actually that's the conceptually tricky part, right? How do you really get rid of it? So you shove it into tools, basically, is the short answer. So given that the nice thing about the fact that there's no global scope is that I'm forced to be very explicit about all the things I'm depending on, right? They're all listed here. I know that this whole module, the only thing it cares about from the rest of the world are these two things, the error class and the ordered collection class. There's no other dependencies. Strictly speaking, it has no dependencies whatsoever because it's completely parametric. But it does expect to be instantiated and have access to these two things. So that's kind of nice from a modularity perspective. The other thing to notice is, because of this, the only way I can access the world or do any damage in particular to the world is by the things that I'm given here, right? So it's running in a sandbox, right? Every top-level class like this, that's a module definition. It sees nothing else. Everything else is plugged into it, and it is effectively its own sandbox, right? So the arguments to the factory method are the capabilities that you get, because this works with. This is a perfect fit with Mark Miller's sort of object capability model, which I don't know how many of you are familiar with. But basically, the idea there is that right, objects represent capabilities. Rather than checking security by finding who's allowed to do what, the idea is that you're allowed to do anything with what you have, but access is controlled by whether you actually get those things. That, if you have an object that can do something, or can give you another object that can eventually do it, then you can do it. And if you don't, there's no way to do it. And so, for example, we know that this class will never use reflection. We know that this class will never call a foreign function. It will never call a VM primitive. There's all kinds of things, because everything is always, all access to everything, including those features, is not through particular language features, but through objects.
Yeah. So top-level classes are modules.
Yeah.
Then my question would be, so the typical feature of modules is that it can define not only dependencies on other modules, but that you also have a notion of interface and...
You have types on the brain, I know. Yes. Okay, so...
I'm just wondering how you use it in practice. If you know that, okay, a combinatorial parser object needs a platform object, but I don't really know what the requirements for the platform object are.
Okay, so there's a long and bitter argument to be had here. But basically, one of the points here is, in fact, that types are useful for defining interfaces between things, for documenting them. Their actually main use is documentation, right? And they are inadequate documentation, because even with the fanciest type system you can name, it doesn't really tell you squat about what the thing is really going to do. Unless you really go completely insane into the Curry-Howard land and really turn it into logic, right? So real type systems will give you some indication, some hint about what might be going on, but really to use any real tool, you have to know what it is. You have to know what it's doing. And you can know what it's doing even if there are no types written at all, because you read about it on the interweb thingy or something, right? Documentation, someone told you what it does. You'd have to do that anyway, because the types alone will never tell you what you need to know. So the interfaces are there for automatically checking certain consistency things. They're not for telling you what it's doing. You can find out what it's doing in many other ways. And this is the case here. Now we actually have optional types which aren't checked yet, but which do give you some degree of documentation. But that's really not the point. You really can live without them. And as far as modularity concerns, types have been a huge obstacle to modularity. The reason that I am able to publish a paper on this in 2010, when this is actually a very simple and straightforward idea, is because most of the people doing research on modularity have been hung up about types, and that has been holding them back, because types actually run counter to modularity. Types propagate everywhere. They're sort of essentially global. They make it really hard to do modularity. Modularity, this thing, okay, here, I'm going to do dynamic system configuration now. Okay, time t0 it was in, time t1 it's out. Okay? Every 6-month-old can do this, right? That's why they sell these little plastic things to stop your plugs in your house if you have small children, because they can configure themselves dynamically. And they may configure themselves in a bad way and crash, and you don't want that, right? This is what actual modularity is about. It is about the fact that this box can be taken and taken away. If it was done like, say, a typical Ada package, then I could not unplug this. This would be statically linked. And then when I went to the airport to go back to the US, I'd take this, and this would take this, and it goes down, and there's a power station somewhere at the other end. And you know what? After 9/11, they've been very harsh about people taking power stations onto the plane. It really, they'll force you to throw it away in a bin before you get on. Mm-hmm. And I'll have to throw this with it, because I can never disconnect it. Right? This is what passes as modularity in most of the typed world, okay? So no. Okay,
Actually, throwing
yeah,
types away means that you have a plug that's not exactly the same, so you can't plug it for that reason.
Right, so it depends, right? With ML, you can sort of unplug things, right? With classic modules, the problem is imports, right? The configuration is statically bound. It never changes. You cannot do anything. You can only have one configuration in a given run. That's, I actually have slides about this, but they take too much time, and I figured I didn't need to go into that in this talk. I actually talked about this at EPFL yesterday. But, I may not convince you, but, sorry. Yeah.
But still, can you, further to the question here, can you statically verify upfront whether the entire instantiation, because it's a system you start somewhere, a root object.
Yeah.
Can you statically verify that all the code that you have will work? That for instance,
generally speaking, no. And with all the type systems in the world, you cannot statically verify that the code you have will work. You can verify whether the type system is set up to verify, and that isn't that the code works. That's why programs crash even inside the type language. Now the kind of things that you do statically verify, you would need a type system to verify, and you can add an optional type system to this. And that's a challenge. That's a research problem, because the idioms we are using are difficult to deal with in the current state of type systems research, right? There's a whole body of research on virtual classes that cannot express the kind of things we're doing here, because they actually are their point of departure was types. And the types impose all kinds of restrictions that make them much less useful and prevent this. Now I have some idea of how I would add an optional type checker to this. But in terms of bang for the buck, it's so far down my list, and in the absence of sub-funding for this project as a volunteer effort, it's who knows when it'll happen. But this is a dynamically typed language. It is not. Its strength is that you can actually flexibly configure things very easily. It doesn't, naturally lend itself to the desire to statically know a lot of stuff up front. So, what else did I want to say about this? A couple of other things that are worth mentioning. So we have a good fit with the object capability security. Also, because this entire library is a class, right, I can have multiple instances of it. what is called side-by-side deployment, right? In Java, you use something like OSGI and class loaders, and it gets rather heavyweight and complicated. If this is a class, you can make obviously you can make many instances because the distinction between a module design and its instances is very important, and you don't tend to see that in hardware. You have to see it, right? If you have a stereo system and it has 2 speakers, that means you have 2 instantiations of the same design. If classes are your module description and objects are your module instance, that works. If modules in the traditional sense as a separate construct are your module design, then typically that doesn't work. You don't really have a good way of creating multiple instances in a given run, right?
One question to the scoping here. So the code in these nested classes, is there an implicit lookup in the outer?
Yeah. Right. So if you look at the paper, there's a description of what the lookup rules are, right? So in principle, even the local variables and the formal parameters are conceptually, you don't actually compile them this way, but you can think of them as also being a lookup into, for a binding that you don't have a good way of overriding, which is why you can compile them reasonably efficiently. But in principle, every name, even platform, is being looked up. At least that's the fairy tale. So side-by-side deployment is something you get, obviously, for free. Of course, you can also have alternative implementations, right? This library has an API. The library as a whole has an interface, just like a conventional object. A single object has an interface, which means you can have multiple different implementations. Say, if you want to replace this implementation with a pack-rat parsing approach or some other approach, you can do that, and the users need not be the wiser.
Is that interface explicitly spelled out somewhere, or is it the fact that a whole bunch of methods come together?
How about yes and no? Or okay, so basically mainly that the whole bunch of methods come together. They're written here, right? You can write up an interface because it happens to be a type expression sublanguage that is optional. There isn't a checker for it, and therefore it's almost certain that this language would have to change in certain ways, because the language we're using is the optional type system I built for Smalltalk once upon a time, and this language is more dynamic than that, and there are issues where that'll probably break down. But its main use, as I said, from my perspective, the main utility of types is documentation, not error checking, and therefore the fact that if I choose to write these types, that's where a lot of the benefit comes from. This documentation is important not only for people but for machines. All the kind of clever IDE tricks that you might want to play with refactoring or name completion rely on the documentation aspect of types, not on the formal correctness aspect of types.
But you said in the beginning, you had one slide which said that you have to code against an interface, right? Not an implementation.
And you have a complete different idea of what an interface is. An interface is a set of named procedures. Okay, that can be late bound. That is the interesting property of the interface. That's why interfaces give you flexibility. It's not about something that some tool formally analyzes. It's not a type. That's not the interesting part about interfaces. Okay. So, what have we talked about? Yeah, we talked about the fact that you can have multiple side-by-side instances. We talked about the fact that you can have alternate implementations. Basically, all kinds of things that you do with regular objects is all lifted to the level of whole libraries because these things can nest. And it's all for free because we don't have to do anything. We just apply the standard, protocols and features that regular objects have. And of course, each of these modules, because there's no static state, unless you choose when you configure them, and in this mythical place we haven't gotten to where you actually tie all this together, unless you actually explicitly choose to share state between them, then they're reentrant, right? They're not going to step on each other because there are no static variables that they are implicitly touching. So this is all kind of good. What else can we tell you that's interesting? Yes, class hierarchy inheritance. Let's see where did we put that? Right. So this class, again, it doesn't really matter what it does. What is interesting about it is it is intended to work as a subclass of the other library. and it has a combinatorial parser class. Remember, combinatorial parser was this nested class that was the root of the whole hierarchy. And we've overridden it here. We look at what we've actually done with it. We've changed some methods, and you'd have to understand what the library does and why we're doing that, and you don't really care, or it would be more convincing if I took the time to walk through all that, but that's a whole talk. But it so happens that, for example, we added a name. So now all the parser objects in this library will have a name, right? And the way this will work is when you create an instance of the surrounding class and ask for any of its nested classes, you access them by this accessor, right? You make the call. At that point, the class gets created. It's very important that, in fact, a nested class is a property of its surrounding object, of the instance of the object of the enclosing class. This is the great number one misunderstanding that destroyed Java nested classes, right? Now, once you do that, you'll have to compute that class. So if we took a class, let's go back and see the original library for a moment. So here, if we went to a class like alternating parser, it's a subclass of combinatorial parser. Now, of course, combinatorial parser here is just a method call. So what happens is when I try to create this for the subclass library, I will call it and I will get the subclass library's version of combinatorial parser. So as a result, the entire hierarchy basically gets bound to the overridden class, right? But essentially, it's the exact same mechanism you have with any method in an object-oriented program where it's calling another virtual method, that it will get rebound in the subclass. Same rules, same mechanism, and you don't have to think. And that's very important because getting rules consistent in a language is very, very hard. The best way is to sort of design it so that this all falls out, because otherwise you have to go keep checking, and the possibility of making a mistake and introducing weird inconsistencies, or the temptation to do it deliberately because it's slightly more optimal and I think I know what I'm doing. Trust me, nobody knows what they're doing. I've been to that movie. So that is basically, this is a case of class hierarchy inheritance. Essentially, we've just specified a few changes to this entire library, and we get a new library with all these new properties. So that's one thing I wanted to actually show you. What else did I want to show you here? So where's Brave New World Explorer? So here is, it doesn't really, this is a class that's a different module. It's a little application that's designed to, as a demo, to do browsing the file system, right? So it just gives you a little window and lets you look at the file system. So again, it's a module. It doesn't really matter. It has a couple of nested classes that represent the way we present, the view of files, the file presenter here, and the semantics of the application, which is the file subject. We don't really care about them. Anyone who's fascinated with this can look up. I gave a talk in Microsoft with a complete demo and a discussion. There's a video of it on the net. The point is, again, we're using the same mechanism, right? We're using slot definitions as imports, effectively. Right? So we have here a file directory, an ordered collection again, and maybe color, things like that are coming from the outside world. We're importing them via our platform parameter. And so the question is, again, how do we configure this? Where does it all get wired together? And it gets wired together via tooling, and I'm going to show you some of this tooling. Here. So to do this wiring, we write an expression that will, instantiate this Brave New World Explorer object and set it up with the right parameters, and that would presumably create the object that I wanted. And this begs a couple of questions, which we will eventually answer, obviously. Right? So here we have this method called main:\args:\. This is very much a close cousin of like main in C or main in Java. Right? It's an agreed entry point by convention. And the difference is that it not only takes a set of, say, arguments that might be command line arguments or something, but it takes a platform argument. Okay, that's what makes it different from those guys. And there's a bunch of code in here that basically sets up, uses Brave New World Explorer, instantiates it with a platform argument, extracts, sends it some message, basically runs the application. right? So this is your configuration code in a way. And it's in the language, and it's in this class. And suspending this belief for a couple of minutes, you can see that if I have an instance of this class, of Brave New World Explorer app, I can send it the main method with a platform object. And so I have a standard procedure for creating it, right? The runtime, the Newspeak runtime, can take such an object, pass it an object that it considers a representation of the platform's capabilities, and we will get a running system, right? There remain several questions, such as how did I get this object? But we'll get to those. But assuming you have this, then you have basically your this object is your binary representation. It's your a.out. And you can call its main function and run the thing. Yeah?
Is that on the top level, Brave New World Explorer app, or why didn't you just lexical scoping for getting access to the platform?
You're getting ahead. We're going to get there. As I said, we have begged several important questions here, but continue to suspend your disbelief just a few more minutes and assume you have gotten this object. Then yes, you can create it. You've created it. You can run the program through this main interface. In particular, you could serialize such an object using basic object serialization, and your binary deployment scenario would be deserialize the object from disk and call main :args, right? And that actually is a scenario we support. So this is the analog of a JVM loading jar files or something, right? Except we don't need class files, jar files, war files, OSGI. You know, one of the points here. This is very much a minimalist philosophy. We're trying to get a lot of mileage out of a few very simple concepts, and you either buy that or you don't. So that's how we do it. And the question, there's two questions that have to be dealt with. One Matthias raised is, where did Brave New World Explorer come from again? Because again, there is this scoping issue, right? And the other is, how did I create this object in the first place, right? Which are both related to the basic, where do I stand, where do I bootstrap and start the configuration. So Brave New World Explorer is again a slot, and yeah, it got imported in some way. If we look at the definition here, it turns out that this particular object, it doesn't even care about the platform. Its factory method is file browser class : it just wants to get the class that it's supposed to work with as a parameter. Okay? So that's its factory method. So that's where Brave New World Explorer came from, but that's sort of one step where it came from. We're still going kind of moving along, and the question is, how did we instantiate Brave New World Explorer app in particular and give it the appropriate parameter, right? And so the answer to that is down here. This is where, as I said, we rely on tooling. By convention, we put this message package using, and what it expects to get is some sort of object representing, conceptually it's the IDE's namespace. It doesn't really care if it's the IDE's namespace. It cares that it is an object that will give it access to the names it needs in order to instantiate itself, right? And what it does, this is a class method. So it's calling file browser class : which is its factory method. And it is passing it the parameter it wants, which is Brave New World Explorer. And where is it getting it from? It's getting it from this parameter, the IDE namespace. So the IDE, which is the one place where you have all the pieces of your program that you may have either typed in or loaded or gotten from the net, that tool, it's just a program, it's just a regular application, but that tool serves the purpose that you usually use a global namespace for that's built into your language. The advantage of that is that you don't have a global namespace in your language, and therefore you do not have all these issues about people accidentally using it and requiring them to use great degrees of discipline and ignore temptations they cannot ignore to just grab it by name and so forth.
But it also means you can't program without the IDE.
This is one tool. You cannot actually program without, say, the file system and a directory system and something like make, which actually goes and uses the file system as its global namespace to find the different pieces that you are putting together. This is doing what make does. And I can make a really ugly, stupid tool with lots of $ and stuff that you type a command line incantation with 20 minus parameters and it'll do the same thing. And I know there are people who would prefer that. I personally am kind of a little more GUI oriented. But it doesn't matter. Ultimately, you are always relying on a tool. Even if you have a global namespace in your program, you still need the tool. So getting rid of the global namespace is net benefit. Because in the end, you're still going to use a tool to put the pieces together. And it's only for putting the pieces together, for specifying a configuration, that you actually need this sort of global namespace. And it really isn't global. It's just the names of the pieces that you need to put together. And you've got them from somewhere. And the typical namespace you use is your directory hierarchy, right? That's where you get the names ultimately for the files if you're doing conventional development. So we're doing it in a slightly unconventional way. Now the nice thing is that, for example, yes, so the tooling can help you here. Given that we have this method, the IDE can detect that we have these methods, and because of that, it knows that this is likely an application that needs to be instantiated. And it knows how to do it. So it knows how to create an object and run it. So it added this link here. And I don't know what window this will show up in. Of course, it showed up on the other window. But, right? So now I'm running this little application. And it lets me look at, the directory structure and whatever garbage is in here, right? It's a very little simple GUI demo that lets you browse the file system. The point is, I created it out of these modules that do not use any global names. I did it via the tooling system. The other thing the tooling system can do for me is, since it knows how to create this object, it knows that, if I wanted to deploy it, one way would be to serialize it. And I can press deploy, and I have two options. One is, that's Newspeak object format. That's basically a serialized object. Now, unlike the typical scenario with serialized objects, one of the problems with serializing an object is you have this little object, you just want to put it out there, and then you have this 50 megabyte file because one thing points at another and you didn't realize how much garbage this thing really is connected to. Now the interesting thing is in these scenarios, again, because of the modularity properties of the language, is that this object, when you serialize it, you'll really get like a couple of 100 kilobytes. Because what does this object refer to? Because it has no global namespace. It refers to its class, and in this case, it refers to Brave New World Explorer, this parameter we sent it in, because that's the only field it had. And that was a class as well, a top-level class, which refers to nothing else, because it doesn't refer to a global namespace. So the only things there are the code. Yeah?
Doesn't it also refer to the platform? Or
No, because if you notice what's happening, the object got created over here, right? No platform involved. It built it by taking this class and passing it in. And if you look at the initializer, right, it didn't take a platform argument. Here, let's.
The platform comes in the next step.
Right. So the only thing this class takes is Brave New World Explorer, which is a class. And that class does not refer to a platform. When you instantiate it, it refers to a platform. When you give it a platform. But the class itself, a top-level class never refers to anything. Okay? That's the whole point. And so all that is there is the pure code. So if I go and choose the deploy option, and so we also have the option of deploying it as a Windows.exe. And I can show you that as well. But if I do this, and where does it? Let's put it somewhere on the other screen. Hello. This directory probably, yes. So I had this directory, and of course I should have shown it to you earlier because these guys weren't there. So it actually puts it out and puts a zipped version of it as well. And right, so this is 12 kilobytes. Okay. Now, to run this, I need a runtime that can load it and do that. And I can do that from the IDE. Well, of course, here I ran it, but I also have the option of, I think the menu's here. Is it here? Run app, yeah. Okay. So if I do this, unfortunately, the projector was not happy when we tried to mirror the display. So what I want to do is dot. And it's going to open it in the wrong place again. right? So again, it's the same thing, but I've done something different here. I've actually asked from a different window that is not pointing at any particular app to just choose an off file from the file system and load this 12 kilobyte little thing that does this browser, right? So that's a deployment scenario. It's not a very realistic one for us because, unfortunately, the world does not grasp the wisdom of Newspeak. And so, think of what Java does. Java does a lobotomized version of the same thing. It's a very complicated, bloated, inefficient way, but they can rely on the fact that through Sun's power, if this thing is stuck everywhere on everyone's machine, and there is a runtime that understands jar files and all this crap, and it loads it, and that. We can't rely on the fact that everybody has Newspeak on their machine. Someday, right? Maybe not. What are the odds? But if everyone was wise enough to run Newspeak on their machine, then here we have 12 kilobyte deployed application. That's why we allow you to do something less attractive, which is to run. Okay, so there's no way. How am I going to show this? I'm going to drag it over here. So this guy is, I believe, a .exe that was created earlier by the same process, right, of this application. I hope it is, because otherwise it's always embarrassing if a demo doesn't work. Let's find out. Yeah, right. That's a .exe. It has like the VM in it and the image in it, and it could be made smaller with more engineering, but it would still be pretty substantial because, deploying all this, because it has to have an engine in it.
So this is
the engine could be a DLL. There's a lot of engineering to be done.
So this is an image-based system, sort of like Smalltalk or Self or the Lisp machine. It's not a source-based system, right?
Okay, so the answer to that is not as simple as yes or no. Currently, this implementation is based on Squeak, which is very much, as you described, an image-based system. Because of these modularity properties, it is very easy, it is relatively straightforward to get away from that. Right? In particular, it is possible to deploy it independently of an image, right? You basically, however you represent the runtime, it's in fact this .exe. What this .exe is an image inside it and linking to the VM and all this, and that's why it's 7 megabytes, right? But it doesn't have to be that way. The point of this talk and of the language is not necessarily the specific engineering of this state, but the fact that the modularity enables you to do a lot more. So maybe I've answered your question. So anyway, yeah, it does the same thing, right? Except that it was from a .exe, right? The really interesting option that I don't have yet. Hello? Yes, of course. That put up a window asking me whether I wanted to quit, but it was in a different window. That was puzzling. The interesting option would have been if we had here another menu item which would say web, right? So kind of working on that a bit, right? We can compile this. I think we can compile it to JavaScript through some hoops. I've got a translator that's pretty far along, does some stuff. You need to think about the GUI. This is the whole GUI is written in Newspeak and is bound to, in this case, to the Windows native APIs by, there's a series of layers, and at the bottom there's a mapping layer. And that mapping layer can be plugged, the idea is to plug in a different one that would map to say something like HTML5. And I've started doing that. So at some point, hopefully in the not too distant future, we would be able to actually run at least some Newspeak applications. There's some things that are really painful to do unless you actually implement a complete VM on top of JavaScript, right? Because some of the things the system can do, which I haven't shown, like, right, it's debuggers written in itself and all these fancy things. Well, JavaScript just doesn't have the primitives to give you access to some of these things. But most application code we could probably deploy this way, and that's actually the actual deployment mode of interest in today's world. And I hope to get there. So how are we doing? We're probably out of time, aren't we?
Well, we technically have the room for another hour.
Okay, so if people want to sit for another 5 minutes, maybe I'll actually finish my talk. Because I try to avoid interactive questions because I know that time gets, your schedule goes out the window. But we're almost there anyway. Was there anything else I wanted to show you? Yeah, there is something I wanted to show you. So this is the IDE. Okay, we have low resolution, and what do I do with that? I don't know what to do with that on this.
You can make the window
Maximum light.
Well, wait, I think I need to bring it over here, and maximizing it won't help. It's still going to be too big. I need to be able to scroll down to where I want to be, and then I want to shrink it from the top, like the man said. I want to bring it back, right? So what I actually wanted to show about here, right, this is a slightly different use of nesting, which is also, it's related to modeling, right? Most domains are hierarchical. So here, this is the IDE, and the nested classes here are things like browsing classes. These are browsing classes for NS, that's Newspeak. These are for Smalltalk. This is for the IDE window. So some of these things are basically just classes that are used for grouping. They're doing what you would do with a directory or something, right? So if I go to the browsing classes, there's a set of classes in them, right? So I'm structuring this. And so, you know, if I want to get a high-level overview of things, it's a lot nicer to be able to do that than to get this long list, because the IDE is a fairly substantial application. And so the nested classes can be used for structuring as well. And so the architecture of this thing really is in the source code and portable with it, and not relying on any kind of external organization. So that is one more thing I wanted to illustrate. And I guess the rest goes to the slides. I can get PowerPoint to cooperate again. So yeah, we've talked about all this. And we've talked about that. I want to talk a little about reflectivity. I just want to mention, right, so I mentioned that how do you resolve this tension between all these fancy, highly dynamic, able to change the program on the fly, change the class of an object on the fly, all these kind of things with the supposed goal of security. And the thing is, this mechanism called mirrors that goes back to self and is present in a lot of systems now. I mean, JDI, the Java debugging interface, is basically a mirror-based system, not coincidentally. The nice thing about that is that's a slightly different approach to structuring reflective APIs, where the reflection isn't tied into every object. In Java, every object understands get class, and then you get the class, and then everything goes from there. Which means that whenever you hand someone an object, you hand them the reflective capability to do stuff with it, right? And then you can start having these fancy checks that go off the stack and try and find out if you're allowed to do that or not, right? Because with mirrors, you basically separate that. The object can't do reflection on itself. You have a separate factory for a reflective object called mirrors, called a mirror, and it can give you mirrors with different capacities. Some mirrors might let you only reflect on your object. Some of them may only let you look at public APIs. Some of them may only let you introspect, all kinds of combinations, right? So you can very fine-grain control of what these objects can do, and you can control whether anyone has these objects or not, because, again, the way we control things here is through actually access to objects. So a mirror is just another capability, and that means that we can support all this reflection, but we can very easily control who gets to do what. So that's sort of the short summary, and there's a whole talk about mirrors on the net if anyone cares. Interop, well, the fact that as I've demoed all this it's running on real Windows. That for Smalltalk for a Smalltalk-like system is non-trivial. In particular, because it's still portable. All this GUI is specified at a very high level, and doesn't really care directly about what API is running underneath, and that's very important. And it also illustrates that we have a really working FFI, which we call them aliens. These are objects that let you talk to the outside world. So from your perspective in the Newspeak program, there is no construct like native method or extern or any of those things, right? You talk to an object, it looks like a regular object. These aliens are objects that make use of particular primitives in the VM, or in some systems the aliens wouldn't be VMware, right? It might be just Java objects or JavaScript objects, and you hide them under this alien API. In this case, there is an alien API that takes advantage of the capability to call out to C. And the capability, because it's in an object, again, you can control who accesses it. Okay, so that's kind of highlights of this. Oh, I forgot about that. So I was going to show you pattern matching, and I was working on a slide, and then I forgot. So we're out of time anyway. And there's lots of related work, obviously. And the most important ones are Smalltalk, Self, and Beta. And the closest thing to the similar approach to modularity is, say, PLT scheme units. But there are important differences. And I think our system is basically, in a way, simpler. We're just leveraging the object paradigm all the way. My argument here is if you actually understood object orientation the way I think it should be understood, that is the correct way, then you don't need all these extra mechanisms. Objects and classes will do it all for you, and they work very well. You know, some Scala, and lots of. There's been decades of research on this, right? We're open source, so Apache 2.0. You know, we're basically a volunteer, unfunded effort at this point, and basically it all works very well together. All these things are of a piece. It synergizes. Whether it's this idea of late binding, virtual classes, mixins, modularity, it works really well for actor-based concurrency as well. Mirror-based reflection, and type systems. Pluggable type systems actually fit in very well here, though there is a real challenge of actually figuring out what the rules would be to properly type check this. This is beyond the state of the art, but we can push that. So yeah, these are some of the people who worked on this. Well, these are all the people who ever worked on this, well, except for some open source volunteers who have done some important work since. But the people who worked on it when it was a real project, and me. And these two guys actually work for this web company called Google. Peter's in Denmark, and Vasily's in Mountain View, and you know they did a fabulous job, obviously. And that's my story, and I'm sticking to it. Yeah.
On the previous slide, it said actor-based concurrency. Or actor. Could you
Elaborate
like in 5 sentences or something?
Okay. So our view is that an actor would be an object which would be bound to a thread of control, and can be unbound to it, right? So, and the particular model we're looking for is we're looking at and we like is the E model, capital E, Mark Miller's language, so it is different, from example, from Erlang or Scala actors. It is in a way closer to the original actor model as Hewitt and Aga described it. But it elaborates on it in some ways, right? So the big difference actually is that there is no blocking receive, right? So Erlang actors and Scala actors are basically Erlang actors written in Scala, have this idea of a receive construct that pattern matches on the message queue of that actor. And this was not in the original actor model, which was more sort of dynamically oriented in a way, and let actors specify replacement behaviors and things like that. And so the effect of doing it the other way is that, again, we kind of unify actors and objects in a deeper way, because we don't have the messages that actors process are defined directly by their methods. Okay? So, you know, and we don't have the blocking receive, which I think is an important issue. I just had this debate with Martin, who has strong arguments, but I
By sending a message to an actor object, you automatically end up in the thread of control that
you would eventually end up with executing the method of that name with those arguments with that actor running on some thread of control with the heap that was associated with it. Okay, I'll go this way slowly.
You didn't mention imperative programming at all. How much of this is actually
imperative?
Yeah.
So this is an imperative language as it stands, but the nice thing, it's very easy at the language level to turn it into a purely functional one, because the only place that you actually define mutable state is when you define a mutable slot, right? Because the access doesn't care, right? So there's basically this one construct in the initializer or in any actually method where you define your slots, And if you define them as mutable, then you have mutable state. And if you define them as immutable, you don't have mutable state. Now, well, and this is a bit of a lie, because the other thing about it is, of course, that you can observe the order, right? Because they're nil initially. Now, what should be added very soon is simultaneous slot definitions, which is sort of a glorified letrec. They're a bit more than letrec. But basically, you will not be able to observe the order. And then if you only use immutables, it'll basically, it'll also handle mutual recursion. Because basically what we'll do is every slot will be initialized to a future for the expression that's actually written there. And then you can do, and this is important for, say, mutually recursive module definitions and stuff like that. At that point, you can basically define, with changing that one construct, or essentially we'd add it, and so you'd actually take out the mutable slots. And then you'd have a purely functional language. Of course, there's a whole interesting questions arise, like, what about all this reflection stuff? So you can change can you change the program, or does that have to go, or is it only a functional language at the base level, but not at the meta level, which is kind of where I'm leaning, right? And the real work is, of course, that because it's an imperative language, all these libraries, you know, they're in a pretty good style, but they certainly have imperative parts to them, and we'd have to redo them, right? We'd have to redo the collection libraries. There's a good way to redo the collection libraries. You take Martin's code and translate it. It'll work just fine. It'll be a lot easier because we won't need to find the higher kind of types and all that rubbish. But it'll just work. So that would be an interesting project. Again, here and there I get volunteers who are interested in it, and we do a little, and we're moving. But it's frustrating, right? Because without money, life is hard. But yeah, and the other idea is, of course, to go further and say, well, let's change the semantics and this functional dialect and make it lazy. And then you have sort of object-oriented Haskell. That's kind of an interesting, though I don't think we're going to need it, because I actually think that if I wanted to do that, I'd go to a pure actor-based language, like you had said, like where every expression is theoretically its own little actor. And it's an optimization problem. But then you don't need monads, and it all goes away. Basically, what he said in 1973, take us another 10 years, but we're going to get there. So, okay, we're getting there, and you still, yeah, okay.
Can you talk a bit about pluggable types? Like, do you envision one program that would adhere to many type systems? Do you see type annotations? Like, what is it?
Okay, yes, I can talk ad nauseum about pluggable types. So, in fact, I have talked, and there are talks, they're probably not recorded, but there are slides on the web and so forth. So the basic pluggable types, the idea of pluggable types is, again, you have to be very careful about the discipline. You have to avoid temptations. So the key idea about my definition of optional pluggable types is they do not perturb the runtime semantics, right? Which is not true of any mainstream type system. In fact, you would be hard-pressed to find a statically typed language where they have been able to avoid that temptation, right? Every language that has types, those types change what the program does, right? Now, the only exception to that I know of is not a real executable language. Of course, lambda calculus, the whole theory of types, that's clean. There, lambda calculus does its thing. The types are purely a mechanism that can tell you if something might go wrong, but they will not change what it does, right? That's because the theory is actually, and another thing about lambda calculus, there's no global names, right? The theory is beautiful. The theory knows what it's doing. The implementations are garbage. So it's very important to do that, because if you let the type system perturb the runtime semantics, for example, overloading in Java, right? That means which method you actually get to run depends on what the type signatures statically were of your arguments. That's one example of things like that. Any temptation to do what, say, the Adobe folks did, where their optional type annotations introduce casts or dynamic checks. All that perturbs things. If you want a pluggable type system, yes, you want to be able to add multiple type systems for different, they're basically like lint, they're optional static analyses. It's important that they do not interact. If they perturb the semantics, they're all perturbing there's some common state that they're all messing with. And therefore they interact, and then everything collapses. There's no way you're going to sort it out. So it doesn't change the semantics at all. The language does what it does. All the type system will do is tell you, according to my rules, this could be a problem. And that's all.
all it ever should do. And you could do this, for various purposes of, the conventional type checking or other kind of information flow, things like that. So that's the shortest expansion on pluggable types I can do.
So some popular dynamically typed languages were missing from the related words, like next, like Python.
Sorry, I didn't catch the last half of your sentence. Popular dynamic language do what?
Were missing from the related words, like Python.
Or Ruby.
Okay, so yeah, that's not a coincidence. Related work means that there really is a deep relationship, either in the history of the ideas or something like that, right? If Python never existed, it would not change what I know or think about dynamic languages one dot, right? These languages are not noted for their intellectual contribution to the state of the art of programming languages. They are particular implementations of ideas that have been successful in the marketplace for whatever reasons, and one can speculate, but they do not bring new ideas to the table. I'm sorry. Everything that you can do in Python, you could do in Lisp decades before and do better, in my opinion. So they're not there for a reason. They aren't related work.
Python tools actually have similar statements that you had about times for documentation. So
They may agree with that. So as far as I know, the whole optional type thing, there's quite a lot of history to this research, and I don't believe that again in sort of in scientific research, who said something first matters, right? I agree with the Python folks on a lot of things. I disagree with some things, but there's a lot of I agree more with the Python folks than probably say the Ruby folks or whatever, because the Python folks are much more software engineering oriented than some of these other communities. The question in related work is whether they originated an idea that is, or have made an important variation with novelty to it on these ideas. And no, they haven't. They've engineered a solution, and it's very popular and very successful, largely because some of these properties exist there. Others don't, but they're not an inspiration for any of this.
Yeah, it's just strange to contrast this language with Java that's fundamentally different, and not contrast it with Python that has some similarities, and then you just explain why is this Newspeak better than same solutions in Python that is a popular language, so you can't just disregard that it exists. You don't disregard Java exists, although that.
Okay, so I actually see more of a relation, because in Java there is the notion of nested classes in Python really don't do anything. They don't really nest in a semantically interesting way. They don't scope properly, unless you can change it, because you can change everything in Python, but they by default don't actually do anything that there's no reason for them to be there in a sense. Nested classes in Java attempted to do something. They do have a semantics. They're kind of screwed up, but I see more of a connection. Now, maybe you see it differently. I do not see a connection really between Python or Ruby or Perl or any of these things, beyond the fact, they're dynamically typed and so forth, but not in the history of the ideas. Did you have something to say, or?
Yeah, that's to the practice of developing libraries now. I see that I seem to have more options how to structure my program. I can depend on another module or request that someone pass me another module or pass me classes directly. And did you find that confusing, or did you come up with a good way to?
Okay, so actually, let me restate that, because at least I think what you said was inaccurate, right? The choice you tend to have is whether you get past maybe you said it right, maybe I misheard. You have a choice between getting past a module definition sometimes, or an instance of it, and deciding to instantiate it once you get the module. You can choose that. That's sort of a design choice to some extent, just like anything else in software program, because we've reduced it from a fixed menu of very limited things that is hardwired into the language to using the general facilities of objects and instantiation and parameter passing. And then you have a greater variety of, these tools can be used in a wide way. We've had some experience with this, right? So we've come up with these idioms of how we do things, but that choice may vary depending on what it is. There's also always the big choice of what are your module boundaries? Where do I? One set of choices involves, do I really structure it as a big giant monolithic class, or do I have a number of small classes and then have some intermediary class where I pull them together and stuff. And some of that was historical because, some things were done earlier and then something was done later by a different developer and things like that. So, you have choices of how to do this. If it's a very large module, you probably don't want to end up with a single thing that's 20,000 or 50,000 lines long. If it's 5,000, that's sort of okay. So partly it's a matter of size, and we probably need more experience on these kind of questions. But we have been able to, the entire IDE is an application structure like that, like I showed, the GUI, the whole GUI framework, which is portable retained graphics, then a higher application level layer. Each of these, they're all fairly sizable modules, and they do a fair amount. So obviously our experience is limited, but it's not trivial.
I still had a question regarding the installation with the as package stuff.
Mm-hmm.
So that it gets the IDE environment. Now that comes from the virtual machine. So say if you wanted to
no, it doesn't come from the virtual machine. It comes from the IDE. IDE is an application.
Okay.
It just has a map, and you ask it to load a class, and then it can read in and call a compiler and so forth, right? Whatever it does, it's just an application.
So in a hypothetical world, if you were working with sort of where you wanted to do your editing in Emacs and then run the program in the end, how would that
Okay, so how would I do? So I could edit. There is a syntax, and you can edit it in Emacs or in VI if you want cold dead fingers or whatever. And then the question would be, what tooling would you choose to use? Right? So you could imagine, like I suggested earlier, if you really want to do that, you could imagine having, NSMake or something, and you put every module in a file, and you write you write a method in just an expression in glue code, and it calls the compiler and compiles it and feeds it to stuff that it read from the file, right? There's interesting mechanics there, but there's nothing really different. It reduces the key observation is you're always going to end up using some tool for the configuration. That's how it's done in every instance. And the only thing is, if you're serious about using that tool, then you realize you don't need the language to pollute itself with a global namespace as a crutch to do that.
But where would the equivalent of the ID namespace come from? Because that's effectively a global, implicitly it's it's not really global because syntactically, but ultimately it's...
So you could imagine, this make tool would read files and match, names of files, domain names of classes, read them in, produce a dictionary, stick them in, or an object really that answers these messages, because it's dynamic. It's very easy to do these sort of things, to have it forward to a dictionary lookup, right? And it would then pass that object in to this method, right?
So it would effectively construct a top-level namespace.
Yeah. Well, okay.
I'm not entirely sure I understand how the IDE updates the class definition. So does it use some method in the platform object for that?
It all works through reflection. Right? This is real reflection. It's not just introspection. That's why it's a dynamic language. That's a misnomer, right? What's dynamic in dynamic languages is the fact that the programs can dynamically modify their definition. That's what makes a dynamic language dynamic. Not by coincidence, they're all dynamically typed, because it's just incredibly painful to figure out a type system to do that. But then basically, it goes through an API and says, okay, add a method, remove a method, create a class, all that stuff. And you had...
I just wanted to know how things can go wrong with your experience in Newsweek. How do you debug things? How do you develop thousands of lines?
I will ignore the temptation to say that they don't go wrong. Of course they go wrong. They go wrong in much the same way as they do, say, in something like Smalltalk, except less, because there's more structure here, because you do have modularity and things like that. But basically, you can get a message not understood. The thing that for type people is hard to understand is that is not the end of the world. Again, using an interactive IDE, most of these actually crop up with some very basic testing, and you fix them as you go along. And it doesn't take you any more time than it does to battle the Haskell type checker. So that's the most common one, of course, is simply when you have nils, right? The equivalent. That's the most common actual problem that might stay in your system after this very initial debugging. And the right answer to that is to have the version where you initialize everything and you never have nils, like the functional one, right? But that's basically the problem. There is a full symbolic debugger. You can modify. I mean, I can demo all this, but we're kind of running late. I can show it to you later, right? There's a debugger that shows you the stack and lets you modify programs on the fly and do fix and continue debugging and all that kind of stuff, right? It's all in the IDE.
Does nil have to inhabit every type? So this seems to be a problem every object-oriented.
Yes. Now, of course, there isn't a type system, but there is. Since it isn't in the sense, since we don't have a formal type system, we don't have to confront this logical inconsistency. But nil is basically an instance of a class called undefined object, and it is everything inhabits it. You can stick anything in anywhere, right? Variables do not have types, right? But if you add a type system to it, it will have that property. Have I exhausted you finally? Good. Thank you for coming.
Thank you.